In this video, let us continue to solve problems based on the first principle of mathematical induction. And we've got a problem here which reads like this. It says, prove by the principle of mathematical induction that for all values of n that belongs to natural numbers, 1 divided by 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 plus ... plus 1 divided by n times n plus 1. You know why it becomes n times n plus 1? Because if there's a number 3, it's multiplied with a number that's greater than this number by 1. So if it is n, it's going to be multiplied by n plus 1. It's going to be greater than this by 1. So 1 by n times n plus 1 equals n divided by n plus 1. Alright, so let us not look too deep into this problem and confuse ourselves. Just go with the steps that we've been doing in the previous videos. So here the first step is going to be, let's say that P of n is the statement which is 1 divided by 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 plus ... plus 1 divided by n times n plus 1 equals n divided by n plus 1 for all values of n that belongs to natural numbers, which is denoted by capital N. Alright, so the next step obviously is nothing but we need to just check this whole thing by substituting the value of n by 1. Let's call that the first step, alright. So the first step is going to be this. The first step is going to be P of 1 is, it's just the first term that you have to consider, right? P of n means the n terms, but P of 1 means just the first term, the one term. So 1 divided by 1 times 2, which is nothing but 1 by 2. 1 times 2 is 2, so it's going to be 1 by 2. So now equals n. So n, you need to replace n by 1. So 1 divided by n plus 1, which is nothing but 1 plus 1, which is 1 by 1 times 2 is 1 by 2. So 1 by 2 equals 1 by 2. So therefore, P of 1 is true for all the values of n that belongs to natural numbers. Alright. So we prove that P of 1 is true. That's the first step. So now what's the second step? The second step is nothing but, it's just an assumption. Let P of m be true already. So if it is true, then what we have? If it is true, we have 1 divided by 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 plus ... plus 1 divided by m times m plus 1 equals m divided by m plus 1. So this is what we have if we assume that P of m is true. Alright. So this is the second step. Now, third step. Third step is nothing but we shall show that P of m plus 1 is true. This is what is going to be the third step. I don't think this much space is sufficient to solve the entire problem. So I'd say let us go to a new page. But what you have to remember before we go to the new page is that this whole thing is equal to m by m plus 1 is what you have to remember. Alright, so I'll come back to this page once we reach this step. Let me continue from the third step. Alright, here we are with the third step. We shall show that P of m plus 1 is true for, this is the question for you to just, not forget it. We don't have to go to the previous page again and again to see the question. So now what we have to do is nothing but, now we did assume that P of m is true. So if P of m is true, we have all the same things, but here we have 1 by m times m plus 1. But when we have to show that m plus 1 is true, we need to include m plus 1, which will definitely be after the term m, right? So this is how it's going to be. It's going to be 1 divided by 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 plus ... plus 1 divided by m times m plus 1. It's not going to stop here because we have to do m plus 1 as well. This is just replacing n by m. But m plus 1 is going to come after this. Plus 1 divided by m plus 1 times m plus 1 plus 1. You're replacing n by m plus 1, which is equal to m plus 1 divided by m plus 1 plus 1, because you're replacing n by m plus 1, right? So now is the time for you to remember whatever I told you in the end of last page. This much is equal to m by m plus 1. Let me show it to you quickly. We have 1 by 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 plus dot 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 plus 1 divided by m times m plus 1 is equal to m divided by m plus 1. Here we have that, which we are going to replace it by m divided by m plus 1 and continue from here, plus 1 divided by m plus 1 times m plus 1 is m plus 2, which is equal to m plus 1 divided by m plus 1, which is m plus 2. So let's just take this left hand side and get to here. All right. So now if you consider this term, if you see both the terms, 1 by m plus 1 is the same in both the terms. So let's factor that out. Let us take it out as common term. So once you take that out, you have m divided by just 1 because m plus 1 has come out, plus 1 divided by only m plus 2 because m plus 1 has come out again. So this is equal to 1 divided by m plus 1. Now we need to take LCM here. LCM of 1 and m plus 2 is definitely m plus 2. So we have this into m plus 2. So m times m plus 2, which is nothing but m square. M times 2 is 2m. And then we're just going to have this as usual. So plus 1 divided by m plus 2 because that's the LCM. Let's continue from this step here. So now m square plus 2m plus 1 can be written as m plus 1 the whole square, right? If you expand m plus 1 the whole square, you're going to get back this. Divided by, we have m plus 1 times m plus 2. So m plus 1 times m plus 2. So which is nothing but 1 m plus 1 gets cancelled with this because there are 2 m plus 1. Because m plus 1 the whole square is m plus 1 times m plus 1. M plus 1 and 1 m plus 1 gets cancelled. And we're left with m plus 1 divided by m plus 2, which can be written as m plus 1 divided by m plus 1 plus 1. So by this what we're going to show is, we show that n is replaced by m plus 1 and this n is also replaced by m plus 1. So which shows that p of m plus 1 is true for this statement for all values of n that belongs to natural numbers. So hence we proved that p of m plus 1 is true. All right. So that ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on the first principle of mathematical induction.